lesson 4B, our last pre-calc lesson before we venture into calculus and start getting real fun. Okay, so that's good. So this one is operations and combinations, or combinations composition of functions. So that's the f of g stuff, f plus g. So we had a chapter on Math 30 on this. Okay, so that's good. So just taking this first one here, f plus g simply means you add the functions and combine like terms. So I can kind of do this one from the top here. X squared plus x squared would be 2x squared. Negative 2x plus 3x would be x. And 1 plus negative 4 would be negative 3. So this would be your f plus g of x function. Can you factor it? Maybe.
No, I'm not even going to do it.
Yeah, there's really no reason to do it. It didn't ask us to solve, so we don't have to really go that far. But if you'd like to, that's good thought. F minus g, so kind of same thing. So x squared minus x squared, that's going to be gone. Negative 2 minus 3 is a negative 5x. 1 minus a negative 4, that's plus 4. So negative 5x plus 5. That's your f minus g function. Okay. All right. Multiplication. F times g. So this is a bit messier because we do have to FOIL out two trinomials, unfortunately. So that takes a little bit of work. So we can line these up. So x squared minus 2x plus 1 times x squared plus 3x minus 4. So it's the same idea of FOIL. Just got to hit three things with each term. So that hits here. I have an x to the fourth. I have a 3x cubed. I have a negative 4x squared. And the next one, a negative 2x squared cubed. Sorry, negative 2x cubed. Then I have a negative 6x squared. And a plus 8x. Okay. And the last three, I have an x squared, a 3x, and a minus 4. That big long string, we just need to combine like terms. So there's only one x4, so x4 stays. I like to cross things out when it's this messy to make sure I don't lose anything. Okay, so 3x cubed minus 2x cubed, that's a 1x cubed. So these two are done. Okay, a negative 4x squared, a negative 6x squared, that's negative 10, plus 1 for negative 9. Okay, 8x plus 3x for 11. And lastly, a minus 4. So there's your FG function. Okay, questions, concerns, comments, complaints? All right, last one, so we're going to divide f divided by g. So this one we can factor, so we will see if we can simplify it. So we have x squared minus 2x plus 1 on top. And we have x squared plus 3x minus 4 on bottom. Okay, these factor to x minus 1 on top. X plus 4, x minus 1 on bottom. And so we get a cancellation there. So f over g of x simplifies nicely to x minus 1 over x plus 4. Okay. All right. So then we have a couple other things here. So it can also be done with trig functions. So just remembering your trig stuff can be helpful. So for example, if I'm doing f minus g of the trig functions f of x and g of x, so sine squared x and cotangent x. So we have sine squared x, and I'm trying to subtract cotangent x. So it's helpful when you're doing trig functions to try to put them as one term or one fraction. So getting a common denominator. So remembering that cotangent is, whoops, not equals. Cotangent is cosine x over sine x. So how can we get these as one fraction? Yep. So we need to put a sine x down here and hit that with another sine x on top. Now you have sine cubed over sine x. So it doesn't really go anywhere from here. So it's just a matter of just knowing you can do that. Sine cubed over sine cubed x minus cos x all over sine x is your putting that together piece. Kind of as far as you can go in that case. Okay, let's draw a line here. Let's look at fg of x. So we're looking at multiply. So this one's a little bit easier because you have sine squared x and you're timesing it to cotangent x. Well, let's write cotangent as cosine x over sine x, and you can see we have a cancellation. That cancels with one of those signs. So the simplified of fg is simply sine x cos x. That's the best case for that one. Okay, so just remembering your trig ratios. I think I would give you trig ratios. I don't think we have to. Probably cotangent. You should know your sine, cosine, and tangent ratios. Okay, so sine is the y over r, that kind of stuff. But we'll have like a trig piece. We'll get back into that stuff. Okay. All right, and then we have some composition of functions. That's the f of g stuff and the g of f. Okay, so we're looking at these functions here. So we have f of x and our g of x. So they did f of g here. So just showing you that means you put the g in for the x's in f. Okay, kind of showing you an example here. So we'll do these two. So our f of x is root x. Our g of x is 2 minus x. So f of g, again, that means you're taking g of x function and putting it into the f function for the x's. All right, so for this one, it'd be root 2 minus x. Right, we take that 2 minus x and put it in for that x, and that's all. F of f, kind of a tricky one. Root x. Okay, so you're rooting it, you could say. Exponents kind of help illustrate this, but you can actually simplify this. I know that looks weird. You can write this as x to the 1/2 to the 1/2. That's root as well. And then what's the power rule? What do you do with the exponents here? Multiply. So it's really just x to the 1/4 or 4th root. Okay, so either way you want to look at it, but 4th root is a cleaner way of writing that. Okay, any questions on that? Okay, g of f. Okay, g of f of x. So that means we're putting in the f into g. So like that. So that means it's going to be simply 2 minus root x. Okay, that root x just goes into the x. And g of g, putting it itself, so it'd be 2 minus x, like that. So you'll see the 2's actually cancel this way, and minus x is just x when you simplify that one. It's kind of nice. All right, last page here. Okay, so we got a triple here, the f of g of h. Okay, so this means you're putting h into g, taking that, putting that thing into f. Okay, so it does take a little bit of process here. So we take the h, we put it right there. Okay, so that means if I did g of h to start, that's going to be root x plus 2 minus 5. Now I have to take this and put it in these two spots. So you have a root x plus 2 minus 5 on top, all over 2 plus root x plus 2 minus 5. Okay, so then we could go root x plus 2 minus 5, and then the bottom, the 2 minus 5 will make up minus 3. Pretty ugly, but that's where it's at. A couple things to pay attention to in this, like restrictions, what makes the bottom 0, different things like that. It doesn't ask us to do that. I'm just kind of getting you to think about those things. Okay, when it comes to domain and range. Okay, all right. This one, so we have if big f of x is 4th root x plus 9, and find f of x and g of x so that it is f of g of x. So basically saying, I know it's kind of confusing sounding, It's basically saying what's the two functions that could create the situation. There's kind of answers vary in this, so you typically go easier. What I mean by that is I'm going to make my f be just 4th root x. Well, then what do we put in for there? X plus 9, right? That was put into the x, which made it look like that for the finish. Just kind of unwrapping the composition is what they're kind of having you understand. Okay, like I said, answers can vary there. But that's a basic example. Any questions on that? All right. All right, last piece. So given f of x is x squared and g of x plus 4, find the composition function and sketch the new function. Okay, so you may need change values in the graphs. So you may need to. So we'll see. So if I put g into here, that's going to give me x plus 4 squared. So we should know what that does parabola-wise. What's an x plus 4 squared do when we insert it? What's that do to the parabola? No takers?
Left 4.
Left 4, yep. 1, 2, 3, 4, so you're right there. And your parabola is the same shape, it didn't stretch at all. So it's going up like that. Okay, and then they want us to do, I'll wait a second. They want us to do f times g though. So it's going to be x squared times x plus 4. It's actually nice to leave it like this because it's factored, so you see what the zeros are. Now, this is we should know, okay, we should know that that's what a cubic looks like, right? A little n that kind of waves. So we know the zeros are at 0 and at negative 4. So back to math 30. Through the negative 4, is that a bounce, a twist, or a straight through? Straight through. And through the 0, is that a bounce, or a straight through, or a twist? Bounce, because it's a 2. Remember, 2 means bounce. So the last question is this a positive cubic or a negative cubic? Positive. So that means it has to start low, finish high. Are we following all my stuff I'm asking? So I'm going to come up here. It doesn't really matter. We're just roughly sketching this. You're going to come up here. You're going to go through this 0, straight through. You're going to come down. You're going to bounce. And you're going to go back up like that. So that's roughly what it would look like. Okay. All right. So we'll stop there.